Solving radical equations that involve two radicals plus another term. Again, my first step is I want to isolate one of these radicals, either the 4x plus 5 or the 2x minus 1. I am going to isolate the square root of 4x plus 5 by moving this radical to this side of the equation. So when I move it over, I'm left with 2 plus the square root of 2x minus 1. Now I want to remove this radical on the left side by squaring both sides of the equation. So when I do that, I square this side and these are going to cancel each other out. When I square the other side of the equation, this is a binomial that I need to square. So I'm left with 4x plus 5 on the left side. When I expand this, because this is being squared, I'm essentially taking this expression and multiplying it by itself. So what we need to do now is we need to FOIL this expression. So we're going to take the first times the first term, which would be 4. I'm going to multiply the outside term times the outside term, which would be plus 2 root 2x minus 1. I'm going to multiply the inside times the inside term, which again would be plus 2 root 2x minus 1. And then I'm lastly going to multiply the last term times the last term. Well, when we multiply a square root times a square root, what happens is this is essentially becomes a square root 2x minus 1 squared. We're multiplying it by itself. So technically this square is going to cancel that radical out. And so I'm just going to simplify the right side of my equation, collect my like terms here. So I have 2 root 2x minus 1s and another 2 root 2x minus 1s. So that would give me a total of 4 root 2x minus 1s. And then because this square canceled this radical out, I'm just left with a 2x. And then I'm going to collect my 4 and my negative 1, which would leave me with a plus 3. All right, so now I have to go one step further and remove this radical. So in order to remove this radical, I again need to isolate this radical. So in order to do that, I'm going to bring the 2x over to this side and the 3 over to this side as well. So 4x minus 2x leaves me with a 2x. A 5 minus 3 would leave me with a plus 2. And I'm left with 4 root 2x minus 1. Now normally I'd want to isolate this radical completely by dividing both sides by 4. But I would only do that if these numbers divided by 4 nicely, and they don't. I would end up with a fraction. So I'm going to leave the 4 over here for now, and I'm going to, when I square both sides, I'm going to have to square this 4 as well. You can only do that when this is a multiplication factor. When there's a plus here, you wouldn't be able to do that. So now in order to remove this radical, I'm going to square both sides. So when we square both sides, we have a binomial squared. So when we expand this term, we're going to get a 4x squared plus, remembering our shortcut, 4x squared, multiply these terms is 4x. Double that value would be a plus 8x. And then I'm going to square this last term, which is a plus 4. On this side, when I square this, I need to square the 4. And then this is going to just cancel that radical out, and I'm left with a 2x minus 1 in brackets that still needs to be multiplied by the 16. All right, so what I end up with is a quadratic equation. I'm going to run this through my brackets. And I get a 32x minus 16. So to solve my quadratic equation, I need to make this equation equal to 0. So I'm going to move this to the other side. So I'm left with the 4x squared minus 24x plus 20 equals 0. Okay, so now how do you solve a quadratic equation? A, by factoring, or B, quadratic formula. So the first thing I notice is that all of these values, I can take out a common factor of 4, just to reduce, make my numbers a little bit easier to work with. I'm left with a minus 6x plus 5. I am now going to factor this. The factors of positive 5 that add to a negative 6 would be x minus 5 and an x minus 1. So my solutions are going to be 5 and a positive 1. Once again, I need to go back and check these answers. So all the way back to my original question, I'm going to substitute in a 4 times a 5 plus 5 minus the square root of 2 times a 5 minus 1 should all equal 2. So 4 times 5 is 20 plus 5 is root 25 minus 2 times 5 is 10 minus 1 is 9. Square root of 25 is 5 minus 3 equals 2. So this checks out. Now I'm going to go ahead and check my other answer. So 4 times 1 plus 5 minus 2 times 1 minus 1 should equate to 2. 4 times 1 is 4 plus 5 is root 9 minus 2 times 1 minus 1 would be root 1. The square root of 9 is 3. The square root of 1 is 1. And so this, in fact, also checks out. So in this case, both of my solutions check out. I'm going to go back and highlight those answers. And that is how you solve quadratic or radical equations involving two square roots.